Hello learners, welcome to Setu Gurukul, and this is the second video of our series on combinatorics, Eeny, Meeny, Miny, Mo. And the topic we are going to deal with today is the factorial algebra. Many of you might be accustomed with this topic, but we are going to try and explain it to ourselves from the most basic principle that leads to the factorial algebra. I'm going to take up an example and using that gradually decipher what factorials are and what the factorial algebra is used for in combinatorics. Let's see. So to begin with, I decide on a situation where there are two people in a room, A and B. And there are two chairs in the same room, chair 1 and chair 2. My query is, how many ways can A and B be seated on these chairs? So you would very simply say they can sit either A on chair 1, B on chair 2, or B on chair 1 and A on chair 2, right? So there's two ways practically. Now, this is an oversimplified example, but I still want you to think of it in a certain algorithm. Instead of randomly thinking of it like A sits on 1 and B sits on 2, or B sits on 1 and A sits on 2, let us develop this habit of thinking in this manner. A comes up, the first person comes up, chooses a chair of the total that are available. The second person comes up and chooses the second chair or another chair of the total that are left, right? So let me repeat myself again. The first person comes up and chooses one out of all that's available, occupies that. The second person comes in and chooses the one out of all that is left, right? So over here, A comes in, chooses maybe one or two, and B has to come in and alternately choose whatever is left off. Now, you might think that how is it really making a change? This way of thinking would actually make a difference when we bring in more number of people, more number of elements in this scenario, right? Where we need a more systematized way of thinking out the matter. So anyway, in a scenario like this, A would come in and have how many choices to choose from? Two choices, right? So A would have two choices, and when B comes in, B would have one residual choice for him or her. So B has one choice. Now the question arises, therefore, total, how many choices are there, right? So A has two choices and B has one choice. So what we learned in our first lecture of and or story, A and B, so A multiplied A's option, which is 2, multiplied with B's option, which is 1. So the total number of choices this way stands at 2. When I'm going to elaborate a little bit more, add a little bit more on this example, you would try, get the essence of how it is different from a regular counting. So for that matter, let me introduce a third person over here, which is A, B, and then C. And same way, there was chair 1, chair number 2, and chair number 3, right? So now A comes up. How many choices does he have? A would have 3 choices, right? So imagine A chooses the first chair. B would come up. B has 2 choices. So B would choose, for the matter of consideration now, the second chair. C comes up and chooses the residual, which is the third chair, right? A comes up again in a different scenario, chooses the first chair. This time B comes up, changes their mind, and chooses the third chair. And C comes up, chooses the remainder of whatever is residual, which is the second chair, right? Now, in a third situation, A comes up again, chooses the second chair, B chooses the first of the two, C chooses the residual, which is this. Again, in a fourth situation, A chooses this one, C chooses or B chooses the last, the third one, and C chooses this. And in a fifth scenario, A chooses the third one, B chooses the first, C chooses the second, or the other way around, like this. This forms exhaustively all the ways they can sit in. But let us try to, kind of pattern it out a little bit more. What is happening? A is coming up, right? He's choosing one of them. Now there are remaining two people, B and C, so they can choose alternately of the two remaining chairs. So any place that A comes up and fix himself on, like let's say position number one in this case. When A comes up and fix himself in a certain place, there are two arrangements, A, B, C or A, C, B, in which B and C decide within themselves on which to go for. Similarly, A comes up and sits on the second place, pins himself down on the second place. B and C again alternatively has two positions to opt for. Again, A comes up, chooses the third place. There are two scenarios of B and C to go for, right? So that way we can kind of, formalize it to really understand instead of randomly thinking how six options are coming. But this is fine. Enumeration is fine as long as you have three or maybe four factors or four elements over here. Beyond that, that becomes a little difficult to really perceive. So what we need is a more, formalized way of thinking, is a more mathematical way of thinking naturally. So what we do is that we bring in A, ask A, which one do you want? So A has three options to them. They can choose from option number one, chair number two, or chair number three. So A is going to choose one of the three options. So the A has three options open to them. Once they choose, we bring in B into the situation. We now ask B that you have got to choose which one you want, right? So B would have two remaining options out there. So B, the number of choices that it has is 2. Now C comes up and there's only residual choice that it has to go and sit on. So C has nothing but one choice. Now, in totality, in the entire situation, what happened? A chooses one out of the three choices, and B chooses one out of the two choices, and C chooses one out of the three choices, right? Here an and factor is coming in. Remember when I discussed and, what did I say? Time and space should not be conflicting. Over here, time is not conflicting. A is not having to choose more than one thing, or A and B are not being made to choose together, right? So A is being given a priority. After that, B is being brought into the picture. After that, C is being brought into the picture, right? So there is not a conflict of time. There is not a conflict of space because there are three comfortable chairs for three of them. So nobody has to compromise on anything as of now, right? So this is a totally defined AND scenario. And what happens in an AND scenario mathematically? You multiply. So three options for A and, which is a multiplication, two options for B, and, which is a multiplication again, one option for C. So the total number of choices would be 3 times 2 times 1. I'm going to take some more time out to go and further elaborate this on four elements and five elements. You need to look into this. Look here. If this was four elements, A, B, C, D, A would have how many choices? And like four chairs out there, one, two, three, four. A would have how many choices? Four choices to themselves. And B would have three, and C would have two, and D would have one, right? Similarly, if I go for five of them, A, B, C, D, E, chair number one, two, three, four, five, it's very easy to guess that there would be 5 times 4 times 3 times 2 times 1 choices. So this is going to form a very, very important tool in the path of combinatorics and understanding it. And this is what we actually define as factorial algebra. Factorial algebra is defined that factorial of a number n, the factorial, let me write it on a fresh page actually. The factorial of a natural number n is defined as the product of all natural numbers which are less than or equal to n. So if you have a number n, like 5, factorial of 5 is 5 times 4 times 3 times 2 times 1. Factorial of 7 is 7 times 6 times 5 into 4 into 3 into 2 into 1. Now the question is, why is factorial like this? It is because of the arrangement logic that I just taught you. How the arrangement logic moves forward in this scenario. For the sake of it, for the simplification of it, for the simple denotation of it in mathematical literature, what we introduce is called the factorial algebra. For a final part, factorial algebra or factorial of a number n is defined as n and then an exclamation mark, which is n factorial, and mathematically that is defined as n times the number smaller than it, which is n minus 1, times the number even smaller than it, which is n minus 2, so on and so forth, till 2 and 1. I hope we are clear with factorial algebra. We understood what the logic is behind the development of this algebra. So let me give a very simple example. Now, if there are 6 people in a room and you want to arrange them on 6 chairs in all possible combination or arrangements possible, what would you do? You would simply do a 6 factorial, right? The first person has 6 choices, second and 5, so on and so forth. Now we don't need to think so much about it. We can simply go for 6 factorial. How much is 6 factorial? To put that into number, 6 into 5 into 4 into 3 into 2 into 1. If you get that done, that's somewhere near a 30 times 12 times 2. So that's 30 times 24, which is 720. That's a large number. So 6 people can be made to sit in different arrangements in a 720 different ways. I hope the discussion on factorial was fruitful. You did understand. If there's anything you didn't, you would want me to explain further, please let me know in the comments. See you in the third video. Thank you.